Good morning everyone. Today we will start equivalent conductance, molar conductance and specific conductance. In our previous video we have already covered conductance, specific conductance, then conductivity and resistivity. You can follow all the videos. Okay, so today we will clearly understand what actually equivalent conductance is, what is molar conductance, then specific conductance, and especially their units. Okay, so first of all their symbol. If I will tell you about equivalent conductance, its symbol is lambda eq. Okay, you can write lambda eq or write like this lambda eq. What is the difference between them? This is capital lambda, this is small lambda. Very simple. Then molar conductance. Molar conductance is lambda m or small lambda m. Clear? Specific conductance symbol is K. Okay, or you can call it conductivity. Very simple. Okay, so first of all we'll clearly understand what actually is equivalent conductance. Okay, equivalence, first of all specific conductance. Okay, in our previous video we have already covered specific conductance, but qualitatively. Okay, now quantitatively, now we have to clearly define what is specific conductance. Okay, to define specific conductance we have to follow a formula, and that formula is what? First of all we have to clearly, let me write here, specific conductance. Clear? So what is specific conductance? Symbol is K. Okay, we all know that a formula, that is R is directly R is equal to rho into L by A. Clear? Okay, by reversing this, or reciprocal of R is called as what? Conductance. Okay, 1 by R is equal to 1 by rho into A by L. That implies that rho equals to, 1 by R equal to C, 1 by rho is equal to A by L. Okay, implies that K is equal to C into A by L. Clear? So here K is called as specific, conductance. Clear? C is called as conductance. Very simple. Clear? Yes or no? Now the point is what? Let me take a simple diagram so you can clearly understand what actually is K. Okay, let me take a solution, because this specific conductance term is specially used in this topic in maximum in solutions. Okay, solutions, different type of electrolytes also used. Okay, let me take NaCl. Okay, let me take NaCl. Let me take NaCl solutions. This is the NaCl solution. Clear? NaCl solution. Okay, so if I take a solution and in that solution I take an area of 1 centimeter. Clearly understand what I tell you here. If I take a solution of NaCl and in that solution I take an area of 1 centimeter length, 1 centimeter breadth and 1 centimeter height, then what happens? In this 1 centimeter cube volume, okay, the volume, let 2 Na plus, let 3 Na plus and 3 Cl minus is actually present. Let just be an example. Let, okay, so let this 1 centimeter cube volume contains, this space contains 3 Na plus ion, 3 Cl minus ion. Clear? Okay, this, if I take here length, area means what? Area means, this is area means length into breadth. Area means length into breadth, length into breadth. Length is 1 centimeter, breadth is 1 centimeter, so 1 centimeter square. Clear? Okay, length equals to 1 centimeter, So what happens to its volume? What happens to its volume? Volume becomes length into breadth into area. Okay, so if I put these values in this formula, what happens? We will get what? K into C. K is equal to C into A equals to 1 centimeter square. L is 1 centimeter. So implies that K equal to C. Implies that K equal to C. That means equivalent conductance, that means specific conductance is equal to conductance when area is, when length, when area is 1 centimeter square and length is 1 centimeter. Okay, so we can say we can define this specific conductance. So specific conductance is defined as is defined as the conductance obtained when movement of ions will took place in 1 centimeter square cross sectional area, in 1 centimeter square cross sectional area with 1 centimeter length in solution. Clear? Very simple. Okay, now come to what? Now come to molar conductance, or equivalent conductance. What is equivalent conductance? What is equivalent conductance? Equivalent conductance symbol is lambda EQ, or lambda, this is like this, lambda EQ. Okay, so equivalent conductance means what? Equivalent conductance is the conductance obtained when 1 gram equivalent of electrolyte dissolved in the solution, called as equivalent conductance. Clear? What do you mean by 1 gram equivalent of electrolytes? Okay, to understand this 1 gram equivalent, we have to understand what is equivalent mass. So let me tell you what is equivalent mass. Equivalent mass of an electrolyte or any substance is equal to amount of solute or amount of electrolyte in gram whole divided by sorry this is wrong. Okay, let me tell you next page. Okay, what is equivalent conductance? Okay, equivalent conductance means 1 gram equivalent. What is 1 gram equivalent? 1 gram equivalent means what? Okay, 1 gram equivalent means we have to clearly understand what is normality. Okay, normality. What is normality? Normality is equal to number of gram equivalent of solute whole divided by volume of solution in liter. Clear? Yes or no? Very simple. So this number of gram equivalent solid also has a formula. This term, this numerator, number of gram equivalent of solute, also has a formula of amount of solute in gram whole divided by equivalent mass. Clear? So if I take number of gram equivalent means 1 gram equivalent. Okay, this when 1 gram equivalent, if I have to take this 1, then this upper term and lower term must be equal. If this is 10, this must be 10. If this is 40, this must be 40. Let me take a simple example. If I have to take 1 gram equivalent of sodium hydroxide. So how can we measure 1 gram equivalent of sodium hydroxide? 1 gram equivalent of sodium hydroxide means, what this means, this term must be 1. So 1, how can be, this term must be 1, how amount of solute must be taken in grams, so this must be 40 gram, because equivalent mass of sodium hydroxide is what? Molecular mass is 40. Its valency, its acidity was 1, so that is equal to 40. So 40 by 40 equals to 1. Clear? This is called as number of gram equivalent of NaOH, that is equal to 1 gram EQVT. Clear? So this must be number of gram equivalent of NaOH is equals to 1 gram equivalent. Clear? Very simple. I hope it is clear to all of you. Okay. Okay. 1 gram equivalent. Very simple, very easy. So I hope all of you clearly understand what I tell you here. So 1 gram equivalent of NaOH, if I tell you 1 gram equivalent of NaOH, that means you have to take 40 gram of NaOH. 40 gram of NaOH you must be take. Okay, to find out, means when 40 gram of NaOH dissolves in solution and that solution gives conductance, that conductance is called as what? Our equivalent conductance. So by using all these terms we get a formula of equivalent conductance. So equivalent conductance means lambda EQ is equals to K into 1000 by C. What is C? What is K? K is specific conductance. K into 1000 by C means concentration. Here concentration must be taken as normality. Okay, we can take it as K into 1000. K into 1000 by what? K into 1000 by normality A now. Okay, very simple. Okay, now come to molar conductance. What is molar conductance? Lastly we will determine their units. Okay, so what is molar conductance? Molar conductance is same like this, like equivalent conductance. The conductance produced when 1 mole of electrolyte dissolved in solution is called as molar conductance. What is the formula molar conductance? So like this, lambda m is equal to k into 1000 by m. M means molarity, k into 1000 by molarity. Clear? I think everyone clearly understand what I tell you here. Now we have to determine their units. Okay, we all know that unit of k or conductivity, unit of k is what? Unit of k is ohm inverse centimeter inverse. This is CGS unit. Ohm inverse means Siemens centimeter inverse. Okay, now we have to find out the unit of lambda eq. Lambda eq, what is lambda eq? Lambda eq formula is k into 1000 whole divided by normality. So k, what is the unit of k? This is ohm inverse centimeter inverse. This is 1000 constant, so no requirement. Normality unit is number of gram equivalent, means gram equivalent per liter. Liter means centimeter, per liter means by centimeter cube. That means ohm in, it must be ohm inverse centimeter square gram eqvt inverse. So this is the unit of what? Equivalent conductance. Like this molar conductance will, we have to write molar conductance here. K into 1000 by m. K is ohm inverse centimeter inverse. This is mole by centimeter cube. What happens here? Ohm inverse centimeter square mole, ohm inverse centimeter square mole inverse. Okay, so I hope it is clear to all of you. So I clearly mention all the units of k, lambda eq and lambda m. In our next class we can clearly understand what is Euler's law. So I think you clearly understand what I tell you here. Everyone please like, share and subscribe to my YouTube channel. Thank you everyone.